Hi friends, this is Jyotsna from konlines.com. In this session, I would like to discuss about the topic indices. Okay, it is the plural form of index that we are having. Now, let me discuss about the topic indexes and indices or indexes. We can call both indexes are used to locate needed records in DB table quickly. Okay, and even for improving the query performance, we'll use the indexes. And we are before discussing this, let me discuss about the types of index in InfoQ. Okay, we are having two types of indexes. Let me show the DFT. Here we are having two types of indexes in index in the InfoQ. This is called as primary index and the secondary index. See here in secondary index, bitmap index and B-tree index. We'll discuss this in detail now. Okay, primary index is default index. We can't change that, it is automatically produced by the system when we activate the data, and secondary we will do some modifications with that. Now why we'll use the index is that to improve the query performance. Okay, creating index is a part of a performance issue on query. As we know that whenever we load the data to the data target, that is InfoCube or might be DSO, in this case we are discussing about the InfoCube, primary indexes are created automatically and use linear search. What is linear search? Linear search is search record by record. Okay. Whereas when we can create the secondary index, it will follow the binary search and hence the query performance will improve. One is primary index and the second one is secondary index. Okay, in this it is the linear search and here it comes to the binary search, so the performance will be improved. And here uh, with an increase of the number of the records in the info queue, not only the load but also query performance can be reduced. This is attributed to the increasing demands on the system for maintaining indexes. Normally, if we consider the sales order or like material orders like that key figures or whatever it might be, quantities or like the characteristics, at that time the obviously the load will be increases. It's like every time it will be increasing quantity, so the increase on the demand it will be increase the load also, and the query performance automatically decreases. Okay, with the increase of the load. For that we are using the indexes. The indexes that are created in the fact table for each dimensions allows you to like key figures. Okay, indexes that are created in fact table for each dimensions allows you to easily find and select the data. When initially loading data into the info queue, you should not create the index at the same time as constructing the info queue. Means when we are creating the info queue, Means initially I'm creating the info cube. At that time you should not create the indexes. Why? Because I load the data like that. So loading performance, it will affect the indexes, will affect the loading performance. That degrades the performance. So we should not create the initial stage of creating the cube, both indexes and the cube. First we should create the info cube, and later afterwards the indexes will be created. Indexes should be created. Okay, if I'm not using the index at the time of loading, I should off the indexes. If already I'm having indexes, at the time of query performance we should on the indexes. The indexes are displayed are the secondary index of F and E fact table of InfoQ. The primary indexes are not displayed. When you activate the objects, system automatically generates an index based on the key fields, and this is primary index. In addition to that, if you wish you want to create some more, if you want to create the secondary index, then we will go for the secondary creation of the indexes, that is bitmap and the b-tree. My secondary index is bitmap index and b-tree index. We can go with any of these two types. Okay. Coming to the bitmap index, it is low cardinality, and B-tree is high cardinality. If I'm having more values in my, means it will be the load is more, then I'll go for the bitmap index. Okay. To improve, and if I want to improve the query performance, it's one of the performance tuning mechanism, and it improves the query performance but degrades the loading performance. So first they will drop the index at the loading time, and they will recreate the index at the time of the reporting. Now coming to the bitmap index, it is the low cardinality values, low cardinal, and coming to the B-tree, it is high cardinal value. Okay. Now we'll go for the navigation. Okay. Let me log on to my SAP system. Select run. Select log on. Give the credentials. Continue. Now go to the RSA11 T code. Why I'm going to RSA11 T code? Now, if I want to check whether my cube is having the indexes or not, check whether the cube has indexes or not. Okay, for this I am selecting my cube RSA11. Now go to the info providers. This is my under modeling info providers. This is my cube, or else I will take another cube if you want. Any cube, you can take any cube where to check the indexes or not. Okay. Here I'm having the index, I'm having one cube SIC underscore MA12 and select my cube SIC underscore MA12. Now select right click context menu, select manage. Okay, now go to the performance tab. Select this, see here under DB indexing info cube SIC for actual sales in 12 in MIP SIC underscore MA12. See here, check DB indexing. See here, it's green color, means indexes are there. Okay, and without index. See here, index green and without errors. Means I'm having indexes in my queue. First, let me delete the index. Now delete DB index batch. Select start. Select apply changes. Now check for DB indexes. Now indexes will delete. See here, no index. Means does not exist. See here, index red has errors or does not exist. Means in my cube no indexes are there. And before discussing that, let me go with this. First, let me explain this. Here, this is I'm having secondary index, primary index. I can't change anything. It's automatically created by the system itself. And let me go to the I'm creating what I have to create. User will create a secondary index. If I wish to create any indexing is additional property. If I wish to create is my secondary index. So here I'm having two types of index. One is bitmap index and one is the B2 index. Bitmap is like it is like a binary value. See here, observe this 1101 1011. For example, I'm taking this 1010, and this is my C number. C1, C2, C3. And here also I'm having another table C numbers, M number, quantity, material number, sales, and date. Now, according to the number means value, binary value, it will select the C numbers. Okay. Like bitmap index is also like the whatever the primary initially we are doing without any cardinality, checking the cardinality, that is the bitmap. We consider that initially when we are doing the dimensions, that is the that dimension, that is called the bitmap, that bitmap index, properties of the bitmap index. And coming to the B3 index, see here, observe this 1101 is attached to 1101, 1101 is attached to 1101, and observe this like this, it will check, and it will check like this. And coming to the B3 indexing, this is the C1 node and C2, C3. These are my okay, these are my values, and this is the less value, and this indicates the more value. Means C1 1, it indicates the less value in C2 from, means it will, this value will be less than the C1 value, and this value will be more than the C1 value. Okay, less value. C3 is the higher value. Okay, now if I want to check, actually in my what indexing is like, if I want some values from, consider that I am having A to Z numbers. Okay, from A to Z. Means simple way I want to explain. I am having values from A to Z, A, B, C, D, up to so on up to Z. Okay. What system will do actually? If I want from this record to this record, if I want D record, right? Means system will check all these files, right? Means where is the D record? From that it will fetch the data and it will present the D record. Actually this is the process where, how the system will check the data. Okay? From whole records. From means if I am having some, for some values if I am having only 1 to 100. Okay, 1, 2, 3, so on up to 100 records. Okay, I want the record to be displayed. My record is 50 record. I want 50th record. Means it have to check all the records and from that it will check and it will get the 50th record. Means it is checking all the thing. Means here the loading time will be more and even my it will present the report. The reporting time will be more. So for avoiding this, I am creating the indexing. Okay, it will be like for if it is small value means from 1 to 100, it is very easy for the system to find out the 50. But I'm having lakhs of records and millions of records. That time it is highly performance issue. Means load it takes more loading time and even for getting the report it will take more time. To avoid this, to have a performance means better performance, I'm using the indexing. Now from this, okay, for value, I'm taking for 1 to 5 one value and 6 to 10 another and 20 to means just for example I'm taking 30 to 41 like that so on up to 90 to 100. Okay, means with indexes I'm doing this. It will maintain the separate index and assign the values like with the means within this limit, within this limit, within this limit. Now I want the value, right now I want the value of 35. Okay, it won't check the, first it will see what is my index value, what I'm searching for. I'm searching for 35th value. Means system will see the 35th value where which is the place I'm having from 20 to 30 range. So no need of having this one. No, system will check 30 to 40 range. No need of checking this one. It will check. Means it will take the greater value from this. Okay, higher value. What is the higher value? That it will take each higher values from 1 to 5, 10, 30, 40 and if it is 40 to 50, 50 like this it will take and it will check first check for this. It is up to 30. If this is up to 5, this is up to 10, this is up to 30 and means in this limit 35 won't be there. So after 30 to 40 the limit is there. So directly it will go here and it will fetch the record from this 35th record from this. Means it is not checking from these values and these values. Means lot of time is saving. So performance will be faster. It will directly fetch the data from here. So loading and reporting will be very fast. This is the reason we are using the indexing. Coming to the here also the same one. First it will check for this values C2 and C2 it will get the values and C3 it will get the values like this. Means same case. Okay, like this the indexing will be done. And here I don't have any index and now at the time of the loading the indexes will be dropped and after that we will recreate the indexes. So let me go with this. Create the index. Okay. Now same RSA11 with this only. Now see here, create DB index batch. Now select this create index selection. See here immediate means right now. See here date or time, immediate start. Save this and start. See here you will get the ID here, job name BI underscore index followed by the ID. Now select refresh, let it start. Okay, apply changes. Write transport request, yes. Okay, now we will check for the DB index. Initially see here it's not there, right? Now I will check this, check DB indexes. I had created that, see here. Check carried out, it is green color, means index exists, index green and without errors. Okay, now what is my cube SIC underscore MA12, right? And this will be in the fact table. Okay, I have to check this whether indexes are there in SC11 T code with the help of T code SC11, sorry SC14. Okay, check the index. Check the indexes. This is the T code SC14 where I had to check with the key figures, right? /BIC /FSIC underscore MA12. This is my cube. This is the cube. F is the fact, uncompressed fact table, and BI is the business intelligence. C is the customer. Now let me go with this back SE14. Now /BIC, this is the table FSIC underscore MA12 is my cube name. See here dictionary object tables, edit. Now storage parameters, select this. Now see here indexes are created. See, for each dimension it will allocate one index. See here indexes 10, 20, 40, 50 and this one. This is about the, these are the indexes I am having. Okay, for each dimension it will create one index. Totally here 5 are there. Let me check my cube RSA11 and select the cube. Select it, display data model, means I want to check how many dimensions I am having. Okay, see here I am having five dimensions with me. Customer dimension, product dimension, time dimension, data package dimension, int dimension. Indexes also I'm having 5. So for each dimensions it created one indexes. Now this is about the indexing, creation of the indexing. Now I said that if we are loading the data, it's better to, we will drop the indexes. Why? Because to avoid the performance, it will slow down the performance if I'm having indexes. So, and they will recreate the index after loading. Okay, now let me explain about how to drop the indexes. Now, right now I'm having the indexes. Select my cube, select manage, go to performance tab. In the same value I'll get all this. Now check for the DB indexes. See here my indexes are there. Now I want to delete or drop the index. For that the condition is this one: select DB index batch. Even with the process chain, actually in the real time we will go with the process chains. Means for now we are doing this. Selection, go immediate, already it's checked. Save, select start, refresh, apply changes. Now let me check this. Check DB index. See here it's red color, has errors or does not exist. Now let me go to the T code. Why SE14? For what? For checking whether the indexes are there or not. So let me go to the T code SE14. SE14. Now this is the cube, right? Select edit, select storage parameters. Now see here. One second. SE14. Observe this. Initially I'm having 20, 30, 40 also values, but right now I'm not having anything. Okay, see here it's empty. 20, 30, 40 all are empty. Okay, means it deleted the dropped the indexes. Okay, no indexes are there. Now to check whether the indexes are B-tree or bitmap index, I said two types of indexes in secondary indexing, right? Now select your cube. Let me write this. To check whether the indexes are B-tree or bitmap. Okay, in your queue. Now go to the RSA11T code. Why? For info provider or info cube. Now this is my cube. Select context menu, select manage, select display model, display data model. Now select this cube. Here change mode is there. See here change mode. Now select, this is the dimensions, right? Now I want select the properties of any dimension. I am selecting here. I am having customer dimension. In this customer ID is there. So I am selecting the properties, context menu properties. Now observe this. This checkbox is unchecked. High cardinal T is unchecked. Means this is low cardinal value. Means if I will select whether the dimension should be high cardinal or low cardinal. If I am using more sales order like materials like that, it is every time it will be increasing quantity. Means the cube will contain that particular dimension will contain more data. So I will select the checkbox so that it will give the intimation to the system that it is the high cardinal, means more and more values are there. So maintain that as a high cardinal value and maintain that as a bit, maintain that as a B tree. If I am not having that checkbox unchecked, means the high cardinality is unchecked, it will intimate my system that it is low cardinal and it is bitmap. Okay. Now he observe this. This is line item dimension is unchecked and high cardinality is unchecked. Means initially what the system is giving is the bitmap, and after means our observation, means depending on our observation, means for sales order, the every time it will be like increasing value. That time I will give the high cardinality, means it will intimate to the system that I'm having for this dimension it will be having more values, so maintain that as a cardinal value. And high cardinal value, high cardinal dimensions is like checking this checkbox tells the system this dimension has high cardinality and system creates a B-tree index for this. As B-tree is more shifted to in high cardinality than bitmap index, which the system generate by default and use it for general dimensions. B-tree is general. Okay. Means high cardinality, like the B tree is like the high cardinality and the bitmap is the general one, low cardinal value. Okay, this is about the cardinality. If I am selecting this value, okay, it means it is like a high, it has more data, high cardinality. In future also it contains more data. For that I am checking the high cardinality. Okay, now this is like B tree. Okay, the values are more, so it's like a high cardinality. And consider this, what initially is creating is the bitmap. Okay, observe this properties. See here, high cardinality is not there, means low cardinal. We will select this, we will give that to the system that it is maintaining more data. Okay, this is about the indexing. Okay, and the types of indexing. Thanks for watching this video.